Hi, and welcome back to my channel Ed Bhumi Ground for Education. And I am Bhumika Batra discussing the steps and the alternates to be an expertise in a field. In this video, I'm going to discuss about the visualization of similarities, which is also known as VOS software. And this is a software which is widely and mostly used for writing the bibliometric literature review article. Now the question comes, what is literature review and what is this bibliometric term denotes to? So literature review basically are the prior researches which have been done, which have taken place by various authors, and when you are reviewing them means you are reading those literatures, you are considering them in your study to justify your objective is termed as literature review. There are certain methodologies which are adopted for writing the literature review article. One of them is bibliometric. When you are focusing on the author's name, year of publication, affiliations, number of citations, which statistical methods have been applied, geographical location, then it is termed as it's a bibliometric literature review article. So while writing that article, you create certain networks, you take a data from various networks. So in order to combine all those networks together, we use VOS, which is a visualization of similarities. We use this software in order to combine all the networks to a graph. So basically, VOS is a software which is used to create maps based on the network data. For visualization and exploration of these maps of any kind of network data, we use VOS, which is the visualization of similarities software. So the major function of this VOS is to analyze the bibliometric network, which I've already explained what is bibliometric and what are networks. Its functionality is based on two ways. One is to create the maps based on your networks, and then second is to visualize and explore them using various ways, various options which are present in the software. So what does creating maps based on network data means? It means the network which is already available for you, or you can also construct a network by way of scientific publications, scientific journals, researchers, authors, countries, or keywords, which I have already explained that this when you are inculcating all these points into an article, it will be termed as bibliometric literature review article. Now the point comes from where does this network actually constructed or developed. So usually a scholar or researcher develop this construct based on the software like Scopus, Web of Science, PubMed. All these only these three options are available which from where you can create your networks for writing an article, or there are reference manager like RIS, EndNote or RedWorks. So you can also cite your work, you can also create maps based on those reference manager. Then coming to the visualization and exploring maps, VOS provides three ways actually, like network visualization, overlay visualization, and then the density visualization. All these terms I'm going to explain you practically on a software. This is the VOS software interface. It interface has five panels like main panel, option panel, information panel, and so on. So in this video, I'm focusing on main panel. This is the main panel, which is shown right here, the white window. And this main panel has three different visualizations like network, overlay, density. In the network visualization, whatever the map you have created from your data file will be shown here like this. This is how the map looks like. In the network visualizations, every item, these are the items. When you are creating the maps, you have been asked that how would you like to go further, whether with the journal name or the country name or the author's name, year of publication, and so on. So this is how bibliometric literature review relates to with these terminologies, and it will ask you there how would you like to go with the map creation. Whatever option you will choose, for example, in this diagram, the journal's name have been selected. So this network visualization, every item here represented by the labels and circle. You can see the label here, and every label has a small or large circles. So the size of the label name, if you can see, this is the larger label, this is the smallest, this is the largest, and again so on. So the size of label and circle denotes their weight. Weight means how strong are they related to each other, which means higher the weight of an item, larger will be the label like this, and bigger will be the circle of that particular item. For example, the distance between two journals, like from red to purple, the distance indicates that how closely are they related to each other. If they are very close to each other like this green and yellow, then we have a vice versa situation with red and blue. So it denotes that the closer the links between to them relates the relationship, how close they are to each other. If you can see these lines which are connecting these labels and circles from red to purple to green, yellow, blue. So these lines between the item represents the links. This is the link between them. Now what is this link? Link between any pair in map, which means this pair, purple and red. The pair between a map, there is a link, and this link denotes how strongly they are related to each other. What is the relationship between them? How strong the connection is between them. Each link has a strength, which is represented using a positive numerical value. Higher the value, stronger the link. For example, the strength of the link shows that how many publications have co-authored, how strongly they are related to each other. So items and links, they go together and make a network like this. This is a network. There are items, small circles, labels, these are the items, and the lines between connecting these items are links. So the items and links together make a network. And the complete, this, if I talk about particular red, so the items which are grouped together like this red, blue, yellow, green or purple, these items are grouped together and it is known as cluster. So cluster is a set of items included in a map. This is a red cluster, this is a purple cluster, green, yellow and blue. The color of every item will be visualized in the overlay visualization, which was the second part of this main panel, overlay visualization. There are two ways by which items are colored. In this map, if you see, there are two ways. The essentials are, if items have scores, the color will be determined by their scores. For example, blue color indicates the lowest score. They have the lowest score among the network. Green and yellow indicates the highest score. If item colors are user defined, the map will also show user definedly manner. If there are no scores or no user defined color represent, the overlay visualization will also not represented or available. So this is how overlay visualization works. It tells you about their scores and colors. This is an example for overlay visualization where I have told you when the items have scores, the color will be determined by their scores. Like blue color are the lowest one, which has the lowest scores, and green and yellow have the highest scores. If you can see, the green and yellow has the bigger size of circle, so which automatically denotes their relationship, their highest scores. Density visualization, this is the third part of this main panel. It has two variants, item density and cluster density. So item density, here items are represented by the labels as we have seen in the overlay visualization. Each item has a color which refers to how strongly they are, what's the density of that particular cluster. So higher the weights, color is closer to yellow. This is what I explained in the overlay visualization. The colors
green and yellow indicates highest score, whereas blue color indicates the lowest score. The second item of density visualization is cluster density, where the density of items is displayed separately for each cluster. The weight given to color cluster is determined by the number of items belonging to that particular cluster in their neighborhood. This is the example for density visualization as the item density and cluster density. If you can see, the color is very dense here in this area where it's yellow, which represents the highest weight. Wherever the criteria on the basis of which you have created the map, whether it's journal, authors or citation, or year of publication or geographical location, so the closest the color is to yellow indicates there is a higher weight, higher relationship. So this is an example for the density visualization.
That's not all about VOS. It still goes on. We have just covered the basics, functions, terminologies, and its interface panel 1, main panel. The other panel I'm going to discuss in the next video. Till then, keep subscribing, keep sharing, and stay tuned. Bye.